All right, so now we want to do the same thing, but just for a generic g prime of x. This function is nasty. If we did it all by hand, it'd be totally gross. But I'm going to follow that definition. G prime of x equals the limit as h approaches 0 of, I'm going to take x plus h and plug it into this function. So every single x gets replaced with an x plus h cubed minus 5, plug in x plus h, so it's x plus h squared plus 1. So this is g of x plus h, and I'll subtract just whatever g of x is. And g of x is 2x cubed minus 5x squared plus 1, and that whole kit and caboodle is over h. It's hard to keep in mind that this is just a slope formula, right? Like, this is just one y value, and this is the other y value, so that's the difference in the y values. And one x value was x, and the other value was x plus h. So this is just the difference of those x values. It's the change in y over change in x. It's crazy. But I don't want to do all this stuff by hand. That's why I put it in Wolfram Alpha. And I got this nasty Tron expression that I'm going to pause and copy. But you might pause and double check and do this yourself in Wolfram Alpha. And we'll see where we meet up. And it's just a jungle of algebra that we stay calm, we watch our minus signs, and we're careful. And if as long as we do that, it's going to all be totally fine. So let me pause and copy some stuff down. So all of this stuff from Wolfram Alpha, when I copy it down, looked like this. I'm going to pick it up with this plus 1. I'm going to really be careful with this negative sign and make sure I distribute to all parts of what was g of x. So I'll have a negative 2x cubed, a positive 5x squared, and a negative 1. And this entire nasty expression is all over h. Just be grateful you didn't have to do this by hand like I had to do when I was a boy. So we're going to see what cancels. So none of these terms cancel because they came off of Wolfram Alpha, and they would have canceled terms already. So we just need to look at what happens over here with what was not in Wolfram Alpha. This 1 and this negative 1 cancel. This negative 2x cubed and this 2x cubed cancel. This 5x squared and this negative 5x squared. They all cancel, leaving us with 2h cubed. I'm not looking for like terms because Wolfram Alpha put them together for me. So I'm copying down all these things. And the entire thing is all over h. It's a limit as h goes to 0. Anytime we're asked to find a limit, the first plan of attack is to plug in whatever you're approaching. But in this case, as in all cases we've seen so far today, we're getting 0 over 0, which means we can do some extra work. I'm going to just show the shortcut I've been talking around. If every term has an h and there's an h in the bottom, you can cancel one h off of everything. So this h can cross off, and in doing so, I can cross off this h, one of these h's, one of these h's, and then one of these h's to make that a squared. So I'm left with the limit as h goes to 0 of the expression 2h squared plus 6h. Wait. Oh, I almost forgot that x. Minus 5h plus 6x squared minus 10x. And now I have something where I can plug in 0 for h. And when I do, this becomes 0, this becomes 0, this becomes 0, and we're left with 6x squared minus 10x, which tells me that if g of x equals 2x cubed minus 5x squared plus 1, its derivative is 6x squared minus 10x. And if you need further convincing, this is a function that will tell me the instantaneous rate of change for any x value I can think of. So if I want to know g prime of 1, I can plug 1 into this function, and I would get negative 4. If I want g prime of negative 1, I could plug negative 1 into this function, and I would get positive 16. Or I could plug in g prime of 0. Or I could figure out when the instantaneous rate of change is 0. There's all kinds of things you can do with a function, but that's how you find it. And if you're super duper duper astute, or just have a stroke of genius, you might see the connection between the derivative and its original function. Something to chew on. All right, guys, good luck. Don't stress out about this. Stay safe. Stay healthy. I'll see you when I see you.